In this video, I want to look at the definition of subgroup. We will look at some easy examples of subgroups as well as some non-examples of subgroups and analyze why they are not subgroups, because it's important to have both examples and non-examples of every new definition that you have in an abstract mathematics class. So let's look at the formal definition of subgroup. We are going to let G under triangle be a group. And I'm going to let H be some subset of G. If H under triangle, the same binary operation that G uses, is a group, then we call H under triangle a subgroup of G under triangle. Much more informally, we're simply going to say H is a subgroup of G. And we write this phrase as H is a subgroup of G. The is a subgroup symbol is just a less than or equal to symbol. And it's just a traditional thing that gets used in abstract algebra. It is important to note that H and G do use the same binary operation. So H and G have the same binary operation in order for H to be a subgroup of G. So let's look at some very basic examples. Well, we know that Z under plus is a group. We know that Q under plus is a group. And we know that the set of integers is a subgroup of the set of rational numbers. And all of this says that Z under its addition is a subgroup of Q under its addition. As another really silly kind of example, we also know that the real numbers under addition forms a group. And hence, and we know that Q is a subgroup of R, so we know that Q under its plus is a subgroup of the real numbers under its plus, and as a consequence, we also know that the integers, which are a subgroup of the rationals under addition, which is a subgroup under the reals, this is enough to say that the rationals are also a subgroup of the reals under addition. If we look at our multiplicative number groups, we also know that Q star under times is a group. And we know that R star under times is a group. And the times operation is exactly the same, so both of these are enough to say that Q star under times is a subgroup of R star under times. It is important to realize that Z star under times is not a group, and hence Z star under times cannot be a subgroup of Q star under times. Even though the set of non-zero integers is certainly a subset of the non-zero rationals. There's another example that I want to look at very briefly, and these are some matrix ideas. We know that M22 under its plus is a group. We also know that M22 under its times is not a group. We know that GL2 under addition is not a group, and we know that GL2 under times is a group. Finally, we also know that GL2 is a subset of M22. This is the set of 2 by 2 matrices. This is the set of invertible 2 by 2 matrices. You get into GL2 by having a non-zero determinant. The fact that the operation for this is plus, and the operation for GL2 is times, means that we have a big note. GL2 is not a subgroup of M22 because GL2's operation is times, and M22's operation is plus. Because the two groups use different operations, GL2 is not a subgroup of M22, and that's worth writing down. So, because GL2 and M22 use different operations, so different operations, we know that GL2 cannot be a subgroup of M22. In order to be a subgroup, you have to have the same operation.